For the second match, now I want to invite the referee and the players. So just give me a second. I want to see it again. Yes. Khalab Girma is going to be the referee for this game. And we have Beimnet Zewdu and Eyob Alemu as great problem solvers that are going to be working on the same problem, one after another. And Khalab, the stage is yours. Okay. All right. Could you please quickly introduce yourself? And Khalab is going to send you the question and let's get started. Thank you.
Okay. My name is Eyob and I'm 4th-year software engineering student in AIT. And I've been part of A2SV for the past 2 years, I guess, since it started. So, yeah, that's pretty much it.
Okay. And if you share your screen, that would be great, Eyob. Thank you.
Okay. Can you see my screen?
Yes, we can.
All right.
So read the question and get back to me.
Okay. Okay. Just missing post. Okay. I got the question, but can I ask some more?
Okay.
Okay. What are the numbers like in the num? Sorry, is this some kind of like 1 to n kind of thing? I see negatives as well.
Yeah, we can see negative numbers, right?
Yeah. Can I have
not a
something like
permutation.
this? Can I have something like this? Let's say -1 or like -2, 1, 2. Like if I have this, what would be the answer? 0?
It would be 3. 0 is not a positive number, right?
Okay, 0 is not considered as positive. Okay. Okay. Let's see. Okay. If it was like this, it would be 1. Okay, got it. So the minimum positive number, like between the other positives, right? Like if it starts with 1 and it continues like consecutively, can I have duplicates?
Yes, we can.
Okay. If this was the case, still the missing number is 3.
Yes.
Right. Okay, give me a sec.
Okay, sure.
Okay. Okay. Right now, if just like if I had to do it like without with extra space, what I would do is I would iterate until the maximum element here in n, which is, oh, actually it's big. Yeah.
Eyob,
One thing, yes, one thing I'm thinking is if there are like n elements, at least 1 to n should be present in the array, in the nums array, basically, right? Because if there is positive number missing, it shouldn't be between these numbers. Then, so I can try to look for these numbers in the nums array, but I just not sure how to do it without using another space. That's what I'm thinking.
maybe you could go through a non-constant space solution first and talk about that.
Okay. Okay. What I would do is, for example, I have, let's say, 1, -1, 3, and let's say 4, right? If I have this nums array, my n is gonna be 4, and if there's no, if like, let's say there's no there's not any number like missing from this currently, like the missing number is above n, let's say 5 was missing. In that case, from 1 to 4, they should be present in the nums array. So what I would do is, if I convert this to a set, just to give me constant lookup, and I iterate from 1 up to 4, if every element is present in this set, then the missing number is n plus 1. Length is plus 1. Otherwise, whatever is missing is the missing number, the smallest missing positive. Does that make sense?
Yeah.
And this would be like n space, because I would be using this set to keep track of, to give me like constant lookup. So
Could you maybe describe to me what having an extra space, how it's helping us?
In this case,
Mhm.
in this case, it's helping me like to look up the elements basically, so whether they are present or not. Yeah, otherwise I would have to do it like iterating through nums, basically, like and that would be n square. It's not gonna be n. So the extra space, I'm using it to basically like minimize the cost of searching.
And we maybe reverse engineer from this to try to come up with the constant space solution.
Constant space, but how many? Do you have only one constant space solution?
Yeah, only one. Like I will change the numbers into negative ones, and it
I can hear someone.
I can find
You would change the negative.
if I have
numbers
two, I have two.
Emre, you guys are speaking. Maybe we shouldn't be able to hear that.
Okay. I need to check whether the presence or not. Let's see.
So you told me about the final array, not the final array, but the missing number being between 1 and n, right?
Yes.
Okay, so far we were clear. And could we maybe use existing space to do what the set is doing for us now?
Yeah, actually, let's say missing. let's say one is at this position, two, I can reverse it. This 0 and 2.
Maybe I think we should go for the non-constant space implementation first, and then we'll try to build on that.
Okay. My screen has a black spot, so I have to do this to actually see the screen.
Okay.
I hope that's okay. So first, I will convert the nums array to set, and I call it lookup. Then for I in range of longest nums plus 1, and it should start from 1. If nums, if I in lookup not in lookup, just return I, otherwise return done elements plus 1. Yeah, I start with changing it to the set, then I iterate from 1 to n, including n. Then if any of it is not present, then just return I. That's the missing number. Since it's going from the smallest to the biggest, this will guarantee to return the smallest. Otherwise, the missing number is n plus 1. Does that make sense?
Yeah, it does. Are there any edge cases you want to try it out on first?
Let's say what happens with this case. -1 and -2. Just this, like it's still 1, right?
Uh-huh.
And so 1 is present. And that is being empty. Can't. Right now, I don't see any edge cases like it works with this. This was 0 and 1.
I think it looks good too.
Yeah.
You can try it out.
Yeah. I don't see any edge cases. Should I submit or? Okay.
Okay, so now I want you to think about how you could use your existing space, which is your nums array, or what you would store on your sets.
Yeah. So what I was thinking is, I can manipulate the array, like let's say, for example, I was given something like this, let's say. And I can say, when I find 2, I can try to place it in its right position, which is the number -1 and swap it with whatever that element is, as long as this position has its own right value. So in this case, 2 should go here. Then it should swap with 3. Then 3 is not in the right position, so it will swap with 4. Let's see. This would be 4 and this would be 3. Then 4 is not in its right position, so it can swap with 1. Now, once I'm done with this process, like I will try, since 1 is in its right position, I will try to check this, it's in the right position. Do the same thing for this. Everything is in its right position, right? Then now I can do like for I whatever, then check whether that index has a value or not. If it has a value, then that number exists, and if it doesn't, that's the missing number. But let me see if there are duplicates. How should I handle it? So if there are duplicates, for example, when I try to place this in its right position, if 1 is already like present in that position, I can just ignore this one and move on. So if I have 5 here, 5 will swap with 1, and this doesn't have anywhere to go, so it doesn't matter for this one. But yeah, and 6 is missing, so 6 would be returned. Does that make sense?
Yeah, it does.
Yes, and if there are elements above, like the length of the array, for example, 10, 12, like something like this, I can also just ignore it because it shouldn't be even present in this. Basically, that won't be my answer. So I can ignore it just like I did for the duplicates. The same is true for negative numbers. If it's negative number and it's like placed somewhere in the middle, or it doesn't matter where it is, I can just ignore it, and by doing the swappings, it will come to the end and just gets out of the way, I guess. Okay. And this one already checks from the smallest to the bigger I can have. And it does that by constantly looking at the index, the number -1. Then if it's not present, it will just return it.
Yeah, that makes sense. Do you maybe show an example?
Okay, let me use the one of the examples here. These are not good examples, actually. Let's use the second one. Okay. So now at the beginning, I will do the swapping. So 3 is not in its right position, so it should swap with -1. So 3 becomes here, and this is -1. Since this is negative, I just ignore it and move on to the next. And 4 swaps with 1. And 1 is not in its right position, so it should swap with -1. This becomes 1 and this becomes -1. 3 is in its right position, 4 is in its right position, and now I'm done. So the iteration happens from 1 up to 4. So when it tries for 1, the zeros index is present, like 1 is similar to 1. So it doesn't, 1 is present. For 2, 2 and -1 are not equal, so 2 is the missing number. Maybe if 2 was present and 3 was missing, the same is true. 3 and minus 1 are different, so 3 would be the missing number. Does that make sense? Yeah. Okay. Should I implement it?
I think you can start implementing it.
All right. Okay. Let me remove this. At the beginning, I will do the swapping. So for in nums, if num is less than the length of nums and num is greater than 0. Actually, yeah, greater than. I don't really care about 0 either because it doesn't matter. And one more case, num. Sorry. Num shouldn't equal from. Okay, sorry. Enumerate. I need the index as well. Nums and I num. And num minus 1 shouldn't be the same as the I. If this is the case, it's in the right position. So, yeah. The other, maybe I can take this to some other function, but let me just finish it. The other case is num should be different from nums. And num minus I. For to handle the duplicates in that are already being like placed in the, one of the copies have been placed in the right position, but there is another duplicate one. To handle this shouldn't be the same. Then once this is like true, that means it's ready to be swapped. So nums I can be swapped with whatever is in nums I minus num I, and nums num minus 1. So I should actually, this shouldn't be a for loop because I want to continue doing this as long as I is less than in this nums and num columns I, and if this is the case, and if nums I is equal to if the current num size is equal to I, then increment I. Otherwise, just keep it there and loop and until it finds like a matching position. Then once that's done, let me see. Let me debug this one first. Let me check. I think it's doing the right job. So for in range, you can call it J. For J in range 1 to then nums. If nums J minus 1 is different from J itself, return J. Otherwise, return length is nums plus 1. Okay, so and I should initialize from 0 here. So what I'm doing is I take num, then one case is like if it is it should be less than the length, like if there are 7 or the numbers that are greater than the length of the array I currently have, I shouldn't do anything with it. And num also should be greater than 0. If it is negative or 0, it shouldn't do anything. And if num minus 1 is similar to the I, which means if it's in the right position, it shouldn't do anything as well. And if that number is, if another copy of it is has already been placed in its place, it shouldn't also do anything. Otherwise, if this all checks out, it should swap it.
Okay,
And
I think I see what it's doing, but I want to give you an edge case that you might want to try it on. Okay, could you write it down?
Yeah.
2,
2,
3, 4,
3, 4,
-1, -1,
-1, -1,
and 1.
and 1. The answer should be 5. Right?
Yeah.
Yeah. Okay. So it starts with the zeros element, and for 2 is not less than nums. And it's greater than 0, and 2 minus 1 is not the same as the I, and it's not in the right position. There is not element in the right position, so it will swap it with this. Sorry, what was the other number? 3. This becomes 3 and this becomes 2. Again, 3 is not the same as the current index it's in, so it will start working for this, and it will swap it with 4. So this becomes 3, this becomes 4. It does the same thing for 4. This becomes 4, and this becomes -1. Now, since it's greater than 0, it doesn't do anything. And this is not the case either. So I increment this is 1. And 2 is in the right position. So this doesn't do anything, and this becomes true. So 3, the same is true for 3. And the same is true for 4. For -1, it's since it's not greater than 0, it won't do anything. And for 1, it's not in the right position, so it tries to swap it with this. Then -1. Now this check happens, and yeah, I think it's doing its job.
Okay. Do you want to talk about time complexity and space complexity.
Okay, time complexity is ON. 2n, but that doesn't it's ON, as named specifically.
Okay,
the
how does-
space is. How does what?
Could you describe a bit more how setting your eye back to where it was affects your time complexity or doesn't affect your time complexity?
Like setting it back to the original, I'm actually like placing other elements on their right position, which means I won't be redoing it for all of them. So let's say I might do this, might run to n time, like everything would be changing to zeros, the zeros index, like, and I might stay in the zeros index for n-1 elements, but there's the next iteration would only be like just checking whether they're in the right position, and it just finishes. So
but okay, can you tell me what the worst arrangement of numbers would be for given your code?
I guess what would that be? The reversed order of it, maybe. Yeah, maybe. Actually, that's not even. This is 3, 2, 1, something like this. Actually, it's not even. Probably this one. And it starts, it's converting like 4, it's converted
Okay,
3, and yeah.
I think we've run
this
out of
keeps-
time, so maybe we should just run it and then conclude. It's not internet. What did I do? I guess I'm not updating them. Or this shouldn't be the kids, like, yeah, I know how to fix it. What is this? Anyways, going wrong. Okay,
don't
I
know
think
what's going on.
the time is up.
Okay, cool.
Okay, cool. So I think we're done with you. Let's have Beimnet's interview, and then we'll get back with the answer, with the result.
Thank you very much, Khalab and Eyob. And Isa, can we please invite Beimnet?
I've told it.
Thank you. And team, we are halfway done in the second match of the quarterfinals. So we have seen Eyob on Khalab's problem. And now Beimnet is going to go through the same problem as soon as he joins us. And while waiting for Beimnet, if anybody, like our newcomers from the discussion community, have any questions we can answer. You can either write your question to the chat window or unmute yourself and ask. And in the meantime, Beimnet joined us. And yes, Khalab and Beimnet, let's continue.
Should I send Beimnet the question?
Beimnet, can you hear us?
Yes, Emir.
All right. Okay. Yes, please, Khalab. And Beimnet, could you please quickly introduce yourself to us?
Okay. My name is Beimnet. I'm a recent graduate from Addis Ababa University.
Feel free to turn on your camera, please.
Okay.
Thank you.
So I'm a recent graduate from Addis Ababa University in software engineering. I have been part of A2SV since 2019, and I'm happy to be here.
Thank you. And good luck. Did you receive the question?
Not yet. Just did.
If you share your screen, we can get started. And Khalab, we are with you.
Okay. Can you see my screen?
Yes, we can.
Okay, so let me read the question in. Give me 2 minutes to read the question.
Okay.
Okay. We're given an array name, and we are supposed to return the smallest positive number in it. So
Okay.
okay. So the array contains negative, right? Negatives. Yeah. And the algorithm we should implement should be linear. So here in this case, we have 0, 1, 2, and the smallest positive missing number is 3. So yeah, I think this is the question, right?
You can see how the output for the examples are the way they are, right?
Yeah. For example 2, we have -1, 1, and 3, 4, and the smallest missing positive is 2. And for example 3, we have 1. Yeah, and numbers can be from each number can be from negative 2 raised to 31 and positive 2 raised to 31 minus 1. Okay. Can you give me 2 minutes to think about an approach?
Okay.
Okay. Okay, so I didn't thought of a well-thought approach yet, but the first thing I'm seeing is if we make the array assets, we can check starting the first positive number if there exists or not, or we can binary search on the range of the numbers starting from 0 to 2 raised to 31 and check if it exists. But here it says to use constant extra space. So yeah, in that case, this approach wouldn't be possible. And okay. So the other thing we can do is, so are there duplicates in the list?
Yeah, there can be duplicates.
Okay. Yeah. So I was thinking to give every number their correct position, to match their index. But if there are duplicates, maybe that would cause us a problem. For example, in this case, I was thinking of giving, making 0 to be in its position, its correct position, which is at index 0, and 1 to like this. And since everything matches, I was thinking of returning 3. But yeah, so
could 0 be an answer?
no.
Okay.
No, 0 cannot be an answer, right? We are supposed to return the first negative, positive number. For example, here, we returned 1. So yeah, 0 cannot be an answer. Yeah. Okay. So would that actually cause us a problem to push everything to its correct position? Let's say there are but yeah, since that would cause us a problem, because the numbers in the list are not from, that does not start from 1 and on increase sequentially from 1, and maybe in the shuffled form of that form. So in that case, we cannot make we cannot switch a number and make it in its correct index, because the number can be here. For example, for 7, we cannot move 7 at the 7th index. Okay, can you give me 1 minute to think?
Yeah, sure.
Oh, okay. So I was my first thought was to make every index move to its to make every element move to its corresponding position. And the reason I back up from that problem was, that approach was, since there will be numbers that are out of this range. By range, I mean the lengths of num and their indices. So, but here I shouldn't care about that, because if there is 7, if there is no a 7 index, I cannot move 7 to this position. It means 7 is out of range, out of this range, and it means at least there will be some elements that is missing from 0 to 0 to 4, or from 1 to 5, if we consider the zeros index to taking the first element, the first positive element, and the second index to taking the second positive element. So for example, here 7, we try to make 7 move to the correct position, but we can't do that. So so since we can't do that, we just leave, and here we try to make 8 go to its correct position. And since we don't have an index called 8 in this array, so we cannot move 8. Let's just leave it. And 9 is the same, 11 the same, and 12 the same. So in this case, what we can do is we can, after doing that, after trying to move elements to their correct positions, we can do one pass and check the first missing, the first index where there is not a match. For here, the first index where there is not a match is 0 and 7. So since there is no, since 0 is not a potential answer, we can save. We can save. We can make 0 save the first positive number. So for every num number in the array, its index is num minus 1. So if there is one in this array, it should be positioned at 0. So in this case, there is we can't do anything. So we will return the first mismatch, which is here, which happened here, and the index that happened, the index that this mismatch happened is at 0. So it means we don't have 1, so we can return 1. Let's see what we can do for arrays that include negative numbers. So here, let's write the indexes. So for 3, it's not in its correct position. So we can move 3 to its correct position. So here we move 3, we swap 3, we move 3 to its correct position. So we said for every num, its index is num minus 1. So we move 3 to its correct position, which is this one, the index 2, and replace and minus 1 in the 0th position. And I'm not sure what we can do about the negatives. So here, the negatives should not. We can consider them like we did for the positive numbers that are out of the range. By that I mean, if the given input had every positive number in sequence that it's supposed to have, everything will have been matched. And for example, if nums is 1, 2, 3, 4, the first missing positive is not in the list, so it should be 5 in this case, right?
Yes.
Okay, so in this case, it should be 5. So what I wanted to do is I wanted to change the given list, try to change the given list to be in this format where everything goes in its correct position. So if at least one of the numbers in this list is duplicated, or if this list contains a missing positive, the answer should exist in these indexes. Because let's say this is 3. So after trying, maybe I will try to move everything in its correct position. 1 is in its correct position. 3, I'll try to move 3 in its correct position. I move 3 in its correct position, which is 2 here, and 4 is already there. So when I try to compare indices with the numbers, I'll find that at index 1 there is 3. So there shouldn't be 3 at index 1. So I'll return 2. So that's my idea behind. And I'm not sure what I'm supposed to do with negatives yet. So what happens if I kept the negatives in? So what was my previous index, my original list for this one? So here what I did was moved 3 to its position, which is here, and replaced the first number in the array with -1, and -1 shouldn't be part of this array. So and does not have any correct index. Okay, maybe if there is 1 after this, we will be replacing this we'll be swapping this -1 again. So for now, I'm not entirely sure, but let's try to move on. And in the second case, I have 4, and the correct position for 4 is 3, index 3. So I'll move on. I'll swap the 2 indexes, and the result will be like this. And the correct position for I won't leave the current place until I have a number that is out of bound or negative, or until I have matched the indexes. So here I have 1, and the correct position for 1 is 0. So I'll try to move 1 to 0, that 0's index. So this will be 1 and -1. So now I can't do anything about -1. It is out of range, and I try to move on. 3 is in its correct position, 4 is in its correct position. So after that, I'll try to do 1 pass, and I match indexes with numbers. So here it is matched, here it is not matched. So the answer should be 2. Okay. Yeah, I think let me try it with some other example.
Okay, try it out with examples, and then we'll maybe get back to the negative numbers.
Sorry?
Try it out with examples, and then maybe we'll get back to negative numbers.
Okay. Yeah. So let's say we have this list 1, 2, and when we see 5, by the indices. So when we see 5, we try to check if there is an index 4, and if there is an index 4, we will try to swap the 2 elements, but there is not. So I will move on. So my conditions to move from the current position is if it is out of range or if it is matched. So my condition to move to the next index is So here is 4. I try to swap 4 with its correct position, which is 3, and I'll do that 4 and 2, and here the indices matched, so I'll move on. So here I'll try to swap. And if one goes out for the index 0 and 5 here, and 5 again is out of bond, and everything is matched. So I'll try to do one pass again, and we know 3 is a missing positive number. So in this case, it's correct. And if I have all positives, and what happens if there is a 0? So in this case, it worked, and I'm curious what should I do for the 0 case? If there is a 0, I can consider it like the negatives, like if it's like it is out of bond and I cannot do anything about it, and I'll move, because if there is 1, it will, if there is 1 later on in this array, it will be replacing this 0. So I think I'll be safe, but I'm not sure yet. So let's try some negative numbers here. What happens if there is almost every negative? Let's see, and maybe 1. So here it is negative. So it is out of range. I won't try to find, I will not try to find an index for it. So move on, negative, and move on. And for 1, I'll try to swap it with, I'll try to move it to its correct position, which is the 0's index. And -2 will be here, and -2 is out of range. So I'll not be touching it, and I'll try to match indexes after it. So this is in the correct position. This is the first mismatch, and I'll return 2 in this case again. Okay, so I think this will handle most of the cases. So if we keep doing this, we will be we'll be using constant space, and time I think would be constant, because if the number is out of range, sorry, were you trying to talk, Ala?
No.
Okay. So let's say if everything is matched, so we will not be, at most we'll be touching every number twice. So yeah, I think this should work. What do you think?
I think it would work too, but so we're good with handling duplicates, right?
Oh yeah, I didn't try out duplicates in the example. Sorry. Okay. Oh yeah. For duplicates, when you try to move them to their correct position. So yeah, duplicate cases, when you try to move them in the correct position, there is already a number there. So we should check if we have already moved. This number, if the current duplicate is 3 here, when we try to move it to its correct position, if there is another 3 like this here, when you try to move it to its correct position, which is index 2, we should check if it is already there, like another duplicate of it already exists, because if we don't, we will be having an infinite loop here. We move 3, we swap 3 here, and it will be infinite. I think that would handle duplicates.
Okay, then maybe we can do some sort of cleanup beforehand to, I don't know, maybe pre-process our array and get every number within a range.
Sorry.
If we're good with handling duplicates, maybe we can do some pre-processing to our array and I don't know, get numbers in the given range, in the range that we know is valid.
Okay, not sure if I understand but
what I meant was maybe we can pre-process our array and then change our numbers that are out of range to some number, I don't know, maybe the minimum number, and not necessarily the minimum, but we can be sure everything in our array is within the range.
Oh, okay. So yeah, yes, that's a good idea. Thank you. What we can do is we know the range of the array and what should be in this array. So what we can do is okay, so we can swap every element. For example, here 7 is in the list. It's not in the range of the array. The range should be from 1 to 5. 7 is greater than 5, so we can drop 7. We can drop 7, and to drop 7, we can maybe swap it with the last element and pop it out. But I'm not sure how much that would help us. But if we do that, the rest of the list we get at the end will be in the we'll change the question, we'll change the problem into no negative numbers and also no duplicates, so that we can easily handle which is missing, or we don't have to drop the array. We can just say, for example, we can point at the last number, and let's use one example. So here our range, so this is not maybe 6 here, and we have here okay, so we should only be having numbers from 0 to 1 to 5 here, 1 to 5, and anything less than or less than 5, less than 1, or if there is a duplicate or that is greater than 5, we can push it to, we can make it at the end of the array. So let's say 6 is at the first position. So for example, here 6 is at the first position. We know that it is not in the given range, so we will swap 6 with 1, and we will make one go in the first in its correct position, and 6 here, and we will have some kind of pointer that will be pointing to numbers that are in the valid range. For example, here this is from 0 to 3 are the numbers that are in the valid range. So at the end, we'll only be trying to match, we'll only be trying to consider numbers that are in this range, and or just pop everything out after this pointer. So let's try to do that, and we must we have 1 in its correct position, and we try to move 3 in its correct position, and here is 3. Let's say we swapped it, and again there is 3 here, and it's 3 is already in its correct position. It means we have a duplicate. So we will move 3 to this position and move our pointer 1 to the left. So what this means is these numbers are not these numbers are not in the range, or they are duplicates. So we can at the end pop everything out.
Beimnet?
Yeah.
Maybe when we find numbers that aren't in our range, that aren't in between 1 and n, we can just turn them into 1, and I don't think that would affect our answer.
Yeah, actually, yeah, we can turn them to some number. Okay, let's try to do that. So here,
Yeah, we could also check, if not check, but we also have to make sure that 1 exists in our array.
Yeah, if we do that, it will mean after we will match, after when we try to match the index with the element, it will say matched if 1 is not in the list.
Yeah.
So we shouldn't, it shouldn't say that. So we have to make sure that 1 exists. Okay, so we can do that. We can change everything that's not in the range to 1, and while doing so, we'll check if there is 1 in the list, and if there is not 1, if there isn't any 1 in the list, we can return 1, and otherwise we can just return the first mismatch. Okay. So here, the first element that's out of range is 6, and we turn it to 1. Okay. And yeah. Okay, let's try one more example is a new concept. I don't think we have much time though. How much time we have, Kala?
We only have 1 or 2 minutes before we hit the 30-minute mark. I think we've already hit the 30-minute mark, if we extend it a bit.
Okay, so let's just discuss.
Yeah, we can do 5 some minutes, because we did something like that for the others too.
Okay. So yeah, we can change everything, as we said. We can change everything in the list, which is not 1, which is out of range, to a 1. And while doing that, check if there exists a 1. For example, here, and we have 7 here, and 0 is out of range, and we can turn it to 1. And we haven't found 1 yet. And for 2, we will push it to its correct position, or just for now don't do anything. 5 is also out of range, we can turn it to 1, and 7 is out of range, we can turn it to 1. And after that, we can do our swap one more time, and here 1 is in its correct position. For 2, we'll make it in its correct position, which is to 1, and there is already 1 exists in the position, so we will move after this, and we'll do the same, and the first mismatch will happen here, so we can return it to here.
And because we didn't find the 1 in the previous array, it means that we Okay.
Sorry? If
No,
we,
I was just trying to make sure that there wasn't a one in. You can move on to the next
there
example.
was. Okay. So here, as we can just turn everything to 1, and but there exists 1 initially. So if there exists 1 initially, here 1 didn't exist initially, so the answer should be 1. So we can have a flag. We can have a flag to check if 1 exists or not. And here 1 exists, so we have a flag that tells us 1 exists. And after that, we can try to iterate after the index 1 and return the first mismatch after trying to move every element to its correct position. So our order would be to discard, to change every element to every out of bound element to 1, and swap elements to their correct position. And after that, if there is 1, okay.
Okay, I think we're out of time.
Okay. Yeah, I think this should be it.
Okay.
Thank you very much, Beimnet and Kalab. And Kalab, you have seen both games. Now, let's get your read. What is your feedback?
Okay, you can hear me, right?
Yes.
Okay, first interview was with Eyob. After I gave him the question, he did a good job in trying to understand the question. He went through different examples and then he asked clarification questions. He also tried to see what outputs of different examples would be. But it did take him quite a long time to come up with the non-constant space solution. We had to first implement the non-constant space solution. And it's after that, like past the 20-minute mark, that he came up with the actual solution to the question. And so I also had to provide a couple of hints before he got there. There's that. And there's also the fact that when we finally submitted the solution, it got a wrong answer and the TLE. For Beimnet, Beimnet also did a really good job in trying to understand what the question was about. He described the question back to me. He asked for time to think. He was very clear in where he was. I was able to track him or what he was up to throughout the interview very well. He also described his concerns and his doubts very clearly to me, so I knew where he was positioned. That made it easier for me to interact with him. He also got to the actual solution very fast. It didn't take him a long time. So that was good. He considered edge cases very well, but he got stuck on things that Eyob, for example, wasn't stuck on. Duplicates and numbers that are out of range, we could have just ignored them or replaced them and it could have worked. They weren't really concerns, but he got stuck on those things, and that's what I have on him. So overall, the review or the feedback that I have is this. Do I have to get back with the judgment right now?
You can get maybe a few more minutes.
I have some time to think about it?
Yeah, definitely.
To go over the notes that I took?
So how much time you think you will need for that? Maybe a few minutes would be enough, and we get the evaluation from Minase.
Yeah, after Minase, I'd follow up.
And Kalab, did you have enough time? Now, can we get the winner for the second match?
Okay, I asked a hard question, and I thought it would be a fair question to ask because most of the problem solvers we are interviewing are actually good, and the solution had steps to it, meaning that we can compare their progress on the problem, because it's not a dry and cut, they solved it or didn't solve it type of question. That was why I picked it. It had steps with like a non-constant time solution and then a constant time solution, and then actually getting to implement that. So as far as the verdict goes, Eyob needed more time and hints to get to the solution. And once we actually got to coding it out, he lead at first, and then we got a wrong answer. Beimnet made a very good initial progress. He got past the non-constant time solution very fast, and within very few minutes he was actually working on this optimal solution. But he didn't get to finish his implementation. He didn't get to coding yet. But for that slight reason that Beimnet didn't need that much time to come up with the actual solution, and the fact that Eyob's code didn't work, so it didn't really matter the fact that he coded it out. I'm going to go with Beimnet.
Thank you very much, Khalab, and congratulations to Beimnet, and also thanks for competing, Eyob. As we said, there is no loser in this competition. And now let's get the feelings from second match players. Eyob, would you like to kick us off? So what do you think about the problem? Any points that you've taken from this experience? Is there anything that you would have done differently? Yes.
Okay. First off, congrats, Matt. And also thank you, Khalab. He was really good interviewer, so I like it. To the actual interview, it was good. One thing I would change is I was like caught up in the problem statement, and I was just straight out looking for the brute force solution, the optimal solution. I mean, like I did have the brute force solution, but I wasn't considering it because the problem statements clearly says go for the optimal. So maybe I would have started with that. Yeah, something like that.
Mm-hmm. Thank you. And team, like one general read, it's not just about this match, but in general, we know that some of our teammates, or like in general, some software engineering students or engineering students, we don't come to university with very strong mathematical background. And for computer science, for software engineering, strong mathematical background is a huge plus, and maybe even a necessity in some sub areas of computer science. And for that reason, my message to everyone is brushing up basic level mathematical knowledge. And if we are not very clear in some areas, definitely we should focus on, we should dedicate more time and try to be very clear. Like this is gonna be visible in our annotations. This is gonna be visible the way we think about mathematical problems. Like even some minor points, these may feel like minor points. For example, I think we had a small discussion about whether 0 is positive or not. Like having that type of knowledge clear in your mind can help you to think clearly. So this is my message to everybody. Let's face with that, since not all of us come from private schools. Not all of us have great mathematical background. And if we get a little more clear in this area, it is going to help all of us. Thank you very much, everyone. Thanks for staying up this late on a Saturday evening. And this was the first time we broadcasted these games. Of course, we took some notes for ourselves too, for organization. Hopefully, by tomorrow, we are going to improve our methodology. And we're not going to see any problems that are already solved by our players. We are going to do that by checking their history of solved problems and make sure they are going to be playing on the fair field on the same problem. And thank you very much, everyone. Any questions, any last remarks before we close today's session? Okay, looks like we are good. And again, congratulations to the winners. And thank you very much for the referees and as well as other players in the game. This was a great experience. Thanks for being part of it. And see you guys in tomorrow's games. Have a good night.